problem. Assembly language platform. Before this, we use the MASM platform. All right. MASM platform is a little bit complicated, especially because you want to write .asm, which is referring to the assembly file, and then you need to link it. Okay, and then once you link it, and then you see in the debug. Okay, there is an easier way. Okay, for you to see the assembly language programming using an emulator. Okay, so today, on the slides, you go to page 85, right? Page 85, where we're going to use the emulator, which is the MU8086 assembler. Okay. All right, so you can download the MU8086 now, right, from the website given. So www.emu8086.com. Okay, and then it will start downloading. Actually, the program is not big. Okay, it's just a few couple of bytes. All right, megabytes. So you can download it quick. All right, and then we're going to start to use it. So mu8086.com. So are you guys in front of the computer? In front of the PC?
Yes.
Sorry. That give you a different website. As I open it, okay, so you can go to the website. Okay, as I just paste it on the chat box. Okay, so you can go there. All right, and then download the program. Okay, once you download it, okay, and then try to just install that, right? Okay, have you guys managed to install that?
On the way, Doctor.
On the way, okay.
Still downloading.
I'm going to also share that. Okay, shared that on the WhatsApp as well. So that's the file. If you have problem to download it from the website, so you can you can just either use the file that I shared on the WhatsApp or the one from the website. So either one will work. Okay, once you install that, so basically it will open up. All right, it will open up the file. Sorry, the program. Okay, like the one I show you on the screen.
Kena guna specific template tu.
Pardon?
Is there a specific template? There's a choice here.
Specific template.
Yeah, the software is asking to choose.
There is no, there is no specific template, but actually the software is actually it will open like this. All right, it will open. This is the original one. Once you start the software, and then it will open. Okay.
Oh, mine displays something else. Hold on.
What is shown on your screen? Do you mind to share that with me?
It's the same one, but it's just asking for like a new file, and then there's choices for templates.
Okay, so it's not a problem. You can just close it. All right.
Okay.
Okay. All right. You can go to back to the microdigital.com. There is a program over there. Program 2.1. Okay, you can go to the program 2.1. Okay, where you can follow the one I'm going to write here. This is basically the one that is on the book. Okay, so basically the one I put here is actually you can follow the bottom part of the link over here. Just share it on the chat box and also on the WhatsApp group, as well. Okay, so this program is actually going to add 5 bytes. So that's the purpose of this program. So move AX, so data segment we move to AX, and then we move AX to DS, then we move AX AX to move ES AX to ES, move 0 to AL, and then again add AX to AL, and then X INC C jump 0 again, remove sum, remove AL to sum, and then move DX, move INT21. Wait for any key. And move AH, move 1 to AH and INT 21H. And there is no min and program and min in the MU86, because over here you just directly put the instruction. Okay, so move for C 00H 21H and T21H. Okay, so that's the program. Oh, I'm missing something. Yes, data segment, segment code segment. Segment. So you do define segment first. Segment data segment. You add your data here. Data here. Data in DB. H12, H15, H1FH, 2BH, sum DB, question mark, and then PEDB. Press any key. Okay. Okay, so basically this is what will be shown once you click emulate. So did you manage to see my screen? So this is what when you click emulate, right? Okay, so you will see here. So it will show you step by step. Okay, so what will happen? So basically you will have data segment X, okay, and then you can run it to see. Okay, let's say you want to press any input. Let's say you put number 1. Okay, so that's what will happen. Okay, by writing this program. Do you manage to run the program by yourself? I'm going to save this one. MU86. Micro. I'm going to share you the code. C. Okay, I share it on the WhatsApp so you can download it. Okay, so that's actually the program. Okay, it asks you to, let's say, you want to add, as you can refer back to the notes. So as you remember that on the first program is on about program 2.1. Okay, the program, what the program does is to add 5 bytes of data and then save the results. Okay, and then the data should be the numbers that you gave over here. Okay, so these are the numbers over here. So which one you put in the database, right? And then you sum the data. So this is the data. So the data segment is having this value, okay? And then you will manage to see on the emulator, okay, what is happening. Okay, so let me run again. So let's say I click emulate again, okay, and we run for every single step. Okay. For example, over here, you can see that. Okay, so this is the registers value. So you have AX, BX, CX, okay, and DX. Okay. So you have every value over here is 0, except for C, you have 48, okay, over here. And then DS is also 0. And then the other segment registers, okay, stack segment, okay, internal pointer, okay, and the pointers and also index and DS, ES also having certain values. Okay, and then let's say you run every single step, okay, you see that how it changes, right? So you see when once you move it, you move the value, all right, which is in the data segment, it is 00710. Okay, so this value is moved into the AX. Okay, so it moves 07 into the high bit, and then the lower bit is 10. Okay, and then move AX to DS. So you will see that DS will change, okay, according to the value of AX. Okay, now you see that. Okay. All right. So that's the changes. And you also see that, okay, you go back. Okay. And then this is actually the address. Okay. This is the address. So you see that the address from 07120, okay, where the CS, okay, it start at the CS. So 0 until, okay, it will increase, okay, until any value, right? Okay, you can see that 712, 713, okay. As long as the code is used, okay, you will have the value. Okay, over here is not used, so it is considered as null. So you see how the address is used. Okay, so it takes first 3 address, okay, for the first segment. Okay, you see that at 7122 contains 07, and 7121 contains 10. Okay. All right. So you run next step, and then it will take another 3. Okay. It will take another 3 physical address. Sorry, it will take another 2 physical address. Okay. And 2 physical address. Okay. So you see that AX is moved to DS. Okay, and then the value of DS will change, right? And then AX, so it will move to 2 by 2, right? So only the first one, it will be by 3 physical address. Okay, this is just to initialize the program. Okay, so once you run it, okay, every step you will take 2 physical address, okay, until, okay, if you have you define a new operand, okay, if this value of number is moved to the segment, okay, to the register, it will take up to 3 physical address. Okay, why? Because this one, okay, need to initialize the hex numbering. Okay, it needs to initialize the hex numbering, so that's why it will take up. So you have 0005 H. So that H you need to choose for the another physical address, okay, for this emulator. Okay, so let's go back. Okay, so we run. Okay, we look at the changes on the register. Okay, so AX is moved to DS. So DS now has the contents of AX. Okay, the contents of AX, and then AX move to ES, and then you will see that content of ES will be similar to DS. Okay, it is similar, and then this value 0005 is moved to CX, and then you will see the value is changed at the CX. Okay, so now CX is 05, and then B will be 0, BX will be 0. Okay, and then, okay, now the lower bit of AX will be 0 after this execution. Okay, so it will no longer will be 0710, it will be 0700. Okay. All right. So once that is done, okay, so now the content at the physical address of BX, okay, and the physical address of BX is added to AL. Okay, so you run it, you see that so 25 is given. All right, 25 is given to AX. So mean that the physical address of the BX was 25. Okay, and then increment BX. Okay, and BX will be 0001. Okay, as you increment it, and then you decrease CX. So CX was 05, and then you decrease it to 04. Okay, now it becomes 04. Okay, over there you will have jump instruction. Okay, so over here, jump not equal to 0 or jump not 0. Okay, so if it is not 0, okay, if the CX is not 0, it will jump, okay, to again. Over here again mean that need to add the content of BX to AL. Okay, so you will see. Okay, so the content of BX, okay, is added to here. Okay, the physical address of BX is added to there. All right, so now AX has changed. It will be repeated until CX is 0. Okay, and then we run again. Okay, we run again. Now it becomes 4C. Okay, now it becomes 6B. Okay, now the last one. Okay, now CX has been 0. Okay, so the next instruction will be executed. So over here, AL, okay, value over here, AL 96, will be put into the address of sum. Okay. So that is move. Okay, once it's done that, and then this is depends on the what we input on the key, right? What we input on the key, and then that value is moved to PX. Okay, so we run it. Okay, and then once it's run, okay, so 9 is put to AH. So the content of AX over here will be changed to 09. Okay, now it's changed to 09, and then interrupt. So interrupt, you're going to stop the program. Okay, so that program stops there. Okay, so this is what we're going to input. Okay, so wait for any key. All right, so we need to input something. So this is what will be shown on the screen, and then move 1 to AH. Okay, so AX content over the high content will be 1. Okay, interrupt again, and then okay, so now we need to enter the input because we it asks you, okay, once this command is done, so you know that content that you write over here will be put into the DX. Okay, we will put into the DX. So let's say I want to put 1. Okay, I want this input 1. Okay, so now the content is put, all right, and then you run again until okay, it's interrupt again. Okay, so that's the actually where you put 5 bytes, okay, into the PX. Okay, so you want to add 5 bytes of data. So meaning that you repeat again. Once you add 1, 1, and 1, and 1 again until 5 times. So you add 5 times of data using that program. Okay, so we're going to look at a different program.
Doctor,
Yes,
what's the significance of the key that you're entering?
the significance of?
The key that you're entering. So when you press any key, what happens?
Yes, actually you can press any key.
No, what happens in the program depending on what key you press?
Okay, this is actually you want to execute the program, right? So once you press any key. So let me show you again.
Just means to start the program.
Okay, okay. So it's actually you can press any key on your keyboard. Okay. So the thing is this program, okay, because over here we don't ask actually the input. Okay, we don't ask the input from what we program over here. I'm going to show you another one where we can put some information. All right, we can put some information, and then that will be put into the registers. Okay, so this is just a simple program actually. So actually, the program that is run over here is not actually require you to put to input or to insert any input from the keyboard. All right, so what you press over here, you can either just press space bar and then the program will stop. Okay, so it has no any significant meaning. All right, it is actually just want to terminate the program. Okay, so I'm going to show you a different program where this is more advanced one. Give me a few minutes. Okay, for this one, okay, so this is actually a simple program as well. So where we are going to print the message, all right? Okay, in this program is actually the one, okay, that you want to print out, okay? Print out whatever message that we're going to type. For example, over here, we type a hello world. Okay, so I'm going to copy this and then I paste over there, so you can just copy the code. Okay, so you need to know that it is not automatically, it will be shown on the screen. Okay, this is what let's say on your mobile, okay, on the app. Okay, so you want to show the text, okay, on your program. So how you going to show it? So you must do the printing, okay, the printing function. Okay, so in the assembly language, to do the printing, okay, so this is how we going to write it. Okay, so first we're going to put the name of the program. Say this is program hi, okay, and then this is the initial program. So org 100h, so this is the standard code. Okay, so jump start. Okay, and then jump start. Okay, you will go to the start. Okay, so it won't execute this message. Okay, because this message is in the database. Okay, so this is what is on our database. So for example, over here it is hello world. Okay, so first we look at the message. We call back the message over here. So the message is the one in our database, which is the hello world. So we put that into the DX. Okay, and then we look over here. So we try to emulate. So jump start and single step. Okay, so from jump it will go to the move. Okay, and then message. So what going to be message is the hello world. All right. So this hello world, okay, is going to be put on the DX. Okay. So on the DX, as you can see that over here, okay, hello world. You can see from here, hello world. Okay. HELLO, okay, comma, and then space, WORLD, inverted comma, okay, and then you have the 0D, 0A, and 24H. Okay, so you have this number. So 0D, 0A, 24. Okay, and then until that, okay, it is increased. Okay, it is increased. Okay, so now your DX, okay, your DX contains already the information of the hello world. Now in the DX, it defines it as 01, 02. All right, so once you have that, okay, and then you want to print, okay, so once you put, okay, when you put the hello world on the register, and then how you want to make register to show it on the screen. Okay, so you must print it. So the print function is number 9 over here. So that number 9 should be put on the AH, so to print it. Okay, and then interrupt. So one interrupt meaning that is finished. Okay, and then put 0. Okay, once, so this is just to mention that once you finish display it, so you want to close it, right? You want to close it. Okay, and then this is run. Okay, let's see. Once we run that, okay, to interrupt, to start program. Okay, so this is what will happen after the interrupt. Okay, it shows on the screen, hello world. Okay, so next, move yes, and then interrupt again. Okay, this is just to stop the program. Okay, so usually you just put that initial, all right, at the end of program to stop the program. Okay. So it can be anything, all right. So this command can be anything over here, as long as it is on the AX or AH, it should be fine. Okay. This is just to exit the program. Okay. So wait for any key, meaning that you're going to, let's say I just press the space bar and then it will just stop. Okay, so that's the way you can code it. Okay. So let's say you want to change. there, and then you can see, okay, so that's only just you change the message, okay. So that's just about the print function, okay. So that's how you write the program on the assembly emulator, all right, EMU8086. All right. Okay, so after this, we're going to look further into how we're going to, because certain program, we need to make a decision, right? So we need to make a decision whether, okay, after certain criteria, okay, whether it has just flow, okay, from one step, what is the next step, and then what is the next step. So that must be designed, okay, that must be designed using a flow chart, okay. So we're going to look into that. Okay, so flowcharts is really important before you write any program, okay. So this is going to mention what is actually your purpose, okay, to do the program. Okay, so the flowchart use a graphic symbols to represent different types of program operation. Okay, so this is how you draw it, okay, the flowchart. So you start with a terminal. So the terminal have an oval shape, okay, and then we have the process. So process is a rectangle box, and then if we have the decision, it will be a diamond box, okay. And then if we have subroutine, the subroutine is what we call that if we have an input program, you want to mention that on the other side of the flowchart. Let's say you have a small program, okay, act 5, okay. So act 5 is actually you need to have the input, okay, and then you also have the output once you do the addition. But just subroutine is just you want to simplify the program, so you put the subroutine there. But you need to describe somewhere about the subroutine. Okay, so the flowchart has been a standard industry practice for decades. Okay, so the flowchart templates help you draw the symbol quickly and neatly. An alternative to flowcharts, pseudocodes involve writing brief descriptions of the flow of the code. Okay, sequence is executing instructions one after the other. Okay, so this is the sequence. All right, so the sequence we use the rectangular box. Okay, so one by one. Okay, so you have an arrow. Okay, put one statement and then next statement. Okay, we can also have a condition box, right? So in condition, we have if statement, right? If, then else, okay? If, then, okay? So for example over here, if, what is our condition? If it rains, okay, I will not go out. But if it is not raining, then I will go out. So condition is raining. Okay. So you put raining over here. Is it raining? If there is not raining, then you go out. Okay. If it is raining, okay, so either yes or no. Okay. So over here it will be yes or no. So condition, if it is raining, okay, yes, I will stay at home. Okay. If no, then I will go out. Okay. So it depends on what condition that you chose. And then it comes up to the next sequence. Okay, so this is example. Okay, so maybe we can have, okay, one more again before I forget, that this one is the pseudocode. All right, this is the flow chart, and then this is the related pseudocode. Okay, this is the pseudocode, and this is the flow chart. So pseudocode is we write like the programming code that we write on the assembly language, right? Or other programming platform as well. Okay, so we have over here, if, okay, condition, okay, is, I just said if raining, then okay, you do this statement, okay, not going out, okay, stay at home, as go out. So that's your second statement. Over here, like this one, we have the condition as well. Let's say you might want to add some statement, or you can also not to add any statement. Just go straight to the next sequence, what you need to do. Okay. So for example, over here, you have condition is raining. Okay, no raining, then I will go out. So if it is raining, yes. Okay. I will wait until the rain stops. Okay. Then I will go out. Okay, so that's the relationship. Right, meaning that, so you will wait until the rain stops, and then after that, you will go to the next statement, meaning that over here you will go out. Okay, so that's the example. Okay, so we have also the repeating condition, all right? So we need to repeat until and while do, okay? So it will keep doing it until they reach a statement, okay? Statement where the condition met. Okay, once the condition met, then the statement will be executed. So this is usually we use the while loop. Okay, while loop. So before this, we use the if else statement or for loop. Okay, so while do. Okay, over here, so we have the statement. Okay, I go to school. Okay, and then condition, I forgot to bring my book. Okay, yes or no. Okay, it will be inverted. Okay, sorry, if this one is yes, okay, you go back, I'll go to the school. Okay, I'll go to the school again, and then condition no, then it will continue. Okay, it will continue to the next statement, right? So the way you write on the pseudocode will be repeat, okay, and then write the statement. So go to the school will be repeated again and again until you bring the book. Okay, so that's the repeating statement. Okay, so you also have another one. Okay, you will repeat until Okay, where you have the condition first. Before that, you have the statement first. All right. And over here, it will be repeating. Let's say, is it raining? No, I will go out. All right. Then if it is raining, yes, I'll just stay at home and go back. It will still asking you, is it raining? Yes, and then we still repeat until it is not raining. Then you will go to the next statement. Okay. So in the this pseudocode, it is written that as while, what is the condition? While raining, do, okay, this statement number 1, stay at home, right? Okay, so we have more. Let's say over here, let's say we want to start, okay, count 5, okay, as we just did in our program just now. Okay, so this is our flowchart, right? So over here, we have count 5, okay? So we're going to store that, this 5 bytes, okay, this 5 bytes into the register, okay? So count 5, okay? Add 1 byte, okay? Increment pointer, so your pointer increase, and then decrement counter, okay? And then it will count, okay? This is jump not 0, right? This is your jump not 0. Count, is it 0? The condition, is it 0? No. Then it will repeat again. Okay, add 1 more byte. Okay. And increment pointer. So before that you have pointer as 1, and then now it becomes 2. And then decrement counter. So you start with 5 and then it decreases to 4. Okay. So this is your BX and CX as we just did in our program. Okay, no, it's still not satisfied because it's not yet 5. Okay? It will be repeated until all of these 5 are done, and then count now it is 0. Okay, now decrement, because your decrement counter now is 0, count is 0, and yes, okay, then store sum of this value. All right, and then stop. Okay, this is the pseudocode. Okay, count 5, repeat, add next byte, increment pointer, decrement count until count 0. Okay, so this is repeated again and again for 5 times, and then it becomes 0, then store sum. Okay, so that's the flowchart for the code or for the program that you want to add 5 bytes of data. Okay. Okay, so the purpose of flowchart or pseudocode is to show the program flow and what the program does. So pseudocode gives the same information as a flowchart in a more compact form. So it is often written in layers in a top-down manner. Okay. And code specific, okay, in a certain language or operating platform is not described in the pseudocode or flowchart. Okay, so we can use the flowchart and pseudocode to write code in any programming language. Okay, so that's it for today. Right, that's it for today. So you have learned on how to do the program. Okay, so 2 programs, 2 simple program, and then we will discuss more on the program later on Thursday. Okay, and then we're going to look some of other instruction as well. Let's say you want to display on the screen, okay, what is the resolution of the display, okay, and then how to control, let's say, the keyboard and also mouse. Okay, that will be on the next topic on the assembly language. Okay, so far you have any question?
No, Doctor.
No. All right. So you might want to review again the program. Okay, you might want to review again the program. To see how the once you run each of those instructions in the emulator, okay, it is inserted. Okay, it is inserted into the register. Okay. All right. Okay, that's it from me for today. So let's turn on your camera so we can take picture together for your attendance. So semua dah habis raya belum? Masih beraya lagi?
Dah habis, Doktor.
Habis dah?
Habis dah.
Tak boleh pergi
Doktor.
mana kan?
Pergi dapur, Doktor.
Ada dia lagi?
Dapur.
Nak jumpa awak pun tak boleh. Alright. Okay. I'm going to count from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, give me one more shot. Okay. Alright, thank you. So have a good day. Alright. So I see you again on Thursday. And Assalamualaikum and bye-bye. Okay.
Thank you, Doktor.
Thank you,
Thank you,
Doctor.
Doktor.
Okay, well,
Thank you, Doctor. Thank you, Doctor.
Sorry.